Hello everyone, and welcome to episode 5, working with multi-band rasters in R. Again, I'm starting with the clean RStudio environment. I already have my Geospatial CARP project loaded here. And we can see that here as well. This is pointing to the path of my Geospatial CARP folder. In my Files tab in the lower right-hand corner, I also have the previous 4 R scripts that we created. And again, I see my geospatial carp.rproj file here as well. So again, since I don't have anything loaded in my console, I'm going to go ahead and start a new script by going to File, New File, R script. Now you can also continue working from the same R script from the previous episodes. In this case, I will be working with a new R script, so bringing everything in anew. All right, so let's go ahead and add some information here at the very top. So work with multi-band rasters in R. I'm going to add my name and add, let's say, just the year for now. And in this video, we're going to learn how we can visualize individual and multiple bands in a raster object. Our objectives are going to be to identify a single versus multi-band raster file. We will learn to import multi-band rasters into R using the raster package. And we will plot multi-band color image rasters in R using the ggplot2 package. Some key points here are that a single raster file can contain multiple bands or layers. We'll show how to use the stack function to load all the bands in a multi-layer raster into a file in R. And also we'll show how individual bands within a stack can be accessed, analyzed, and visualized using the same functions as single band rasters. All right, so just a brief recap from what we've done previously. We've learned what raster data is, how to look at it and import metadata information and to plot it. We will also look at raster coordinate reference systems. Those previous examples were with single band raster data, where there was only one layer of information. However, raster data can also be considered multi-band, where there are multiple layers. These layers share the same extent, resolution, and CRS, so that's coordinate reference system. Now in this episode, we will explore how to import and plot multi-band rasters in R. We will use the same libraries as we had previously in other previous episodes. So let's go ahead and start by loading in our libraries. So that's library raster, library open parentheses raster inside, library rgdoll, library ggplot2, and lastly library dplyr. I'm going to highlight all 4 lines, press Ctrl Enter to load those libraries in. So again, it looks like we have some messages here. We have a warning, but that's not an error, and we have some other information in the messages here as well. So again, nothing went wrong here. R likes to have its messages and warnings sometimes in red, even though it's not an error. So just when R will have an error, it'll be very clear and evident that something has gone wrong. So in this case, it looks like everything is good. All right, so a little bit about the data we're going to be working with in this lesson. We will be working with both single and multi-band raster data. The single band raster we will use is going to be called harv_rgb_ortho.tit. All right, so let's go ahead and load in some data. Load in the single band raster. Single band raster. So we're going to create an object called rgb_band1_harv. We're going to use that raster function again from the raster package, open parentheses, double quotes. We're going to navigate into data \raster /harv underscore RGB underscore ortho dot tiff is the file. I press Control Enter. And we can see that in my environment, I now have an object of formal class raster layer, so it looks like everything worked. Now the first thing we want to do is plot this, right? So we want to first convert to a data frame and then plot. So let's go ahead and create RGB underscore band1 underscore harv, underscore harv, and let's add an underscore df for data frame. We're going to use again that function as.data.frame, open parentheses. Let's put in our raster object that we just loaded, and again specify the argument xy equals true. Control Enter. Oops. Pardon me. Oh, this is great. So I had forgotten to save my script, and muscle memory kicked in. So let's go ahead and save this first. We're going to save this as episode 5 multiband rasters.r. Great, so instead of untitled 1 in red, we now have the title of our script here. So that was a happy mistake. So let's go ahead and press Control Enter now to create that data frame. And now we have a data frame also loaded here. It looks like there are 3,044,598 observations with 3 variables, so a very large data frame. And let's go ahead and plot it. So again, it's a ggplot, open parentheses, plus geom underscore raster, open parentheses, data equals RGB underscore band1 underscore harv underscore df, comma, AES aesthetics, open parentheses, x is equal to x, y is equal to y, and alpha is going to be equal to harv underscore RGB, RGB underscore ortho. And our favorite plus, well, my favorite, chord underscore quick map. All right, so before I run this, I want to go ahead and first explain how I knew that alpha is going to be equal to this harv underscore RGB underscore ortho. So again, if you recall, alpha is our transparency parameter. So if I do str or structure of that new data frame I created, band1 harv df, it shows me a preview again of that object, so it tells me it's a data frame. Again, those over 3 million observations, 3 variables, and it tells me what those variables are. So x and y are the coordinates, we're already using those, and then this is the variable I'm interested in actually plotting or sort of filling in. All right, let's go ahead and run this. Again, this will probably take a couple moments, if not a couple of minutes, because again, we have over 3 million observations. Let's navigate to our plots tab, and we'll wait a little bit. Great, and so we have our raster here plotted using ggplot. Again, we have the x-coordinate on the x-axis, y-coordinate on the y-axis, and what's filled in is that harv RGB ortho variable in increasing shades of gray, so from light gray to black. All right, so we're ready for our first challenge, and this one's going to be a bit of a throwback to our previous lessons, so be prepared to use those new skills that you've learned. All right, so again, this is a throwback to some of those previous episodes and lessons that we've just gone through, so feel free to refer to your notes. So challenge 1, attributes. View the attributes of this band, band 1. What are its dimensions, CRS, coordinate reference system, resolution, min and max values, and band number? All right, so let's go through solutions to challenge number 1. So one way we can get at all of that information that was in the challenge is we can just call that raster. So if I press Control Enter, I get a lot of information about that raster. So let's walk through it. So it's of class raster layer. We have one band here, but there are a total of 3. We have the dimensions, so the number of rows, number of columns, total number of cells. We have the resolution here, so 0.25 by 0.25. We have the extent, so the x min and max and the y min and max. We have the CRS, or coordinate reference system. We can see here that the projection is in universal transmercator in zone 18. The units are in meters, so this is 0.25 meters by 0.25 meters. We have the source of where this raster lives on our computer, on my computer, and the name of this raster as well. Great, so let's talk a little bit about image rasters. So as we saw in the previous exercise, this specific raster contains values between 0 and 255. Oops. So these values represent degrees of brightness associated with the image band. In the case of an RGB image, so red, green, and blue, band 1 is the red band. When we plot the red band, larger numbers, so increasing towards 255, represent pixels with more red in them, a strong red reflection. Smaller numbers towards 0 represent pixels with less red in them, so less red was reflected. To plot an RGB image, we must mix red and green and blue values into one single color to create a full color image, similar to the color image you would get from a digital camera. So with that, let's move on to importing a specific band. All right, so we can use the raster function to import specific bands in our raster object by specifying which bands we want, with band is equal to, and then you include a number. To import the green bands, for example, we could use the argument band is equal to 2. So let's give this a try. So this will be import green band. All right, so let's create an object called RGB underscore band 2 underscore har, assignment operator. We're going to use the raster function, double quotes, navigate to data raster, har underscore RGB, underscore ortho dot tiff. And now we're going to move outside of that last quote, add a comma, and specify the argument band is equal to 2. And press Control Enter. All right, so it looks like we have another object, a formal class raster layer. Let's plot this. So again, we have to convert this to a data frame first to plot it. So let's create an object called RGB underscore band 2 underscore har underscore df. Again, the df is for data frame. We use the function as.data.frame, put in our raster, which is RGB underscore band 2 underscore har. Again, we specify the argument xy is equal to true, and press Control Enter. All right, we have another data frame here that has the same number of observations as the previous one, which makes sense, right? As we talked about these multi-layer rasters, they are all layered on top of each other. They have the same extent in CRS, and so it makes sense that it has also the same number of observations. So let's go ahead and plot it. Again, we use the ggplot function, open parentheses, plus the geom underscore raster, open parentheses. Data is equal to that RGB underscore band 2 underscore harv underscore df, comma, AES aesthetics, x is equal to x, y is equal to y, alpha, so our transparency is going to be equal to harv underscore RGB underscore ortho, plus my favorite, chord underscore quick map. Let me press enter a couple times, move this up the screen. All right, so let's go ahead and press Control Enter. Again, this will take just a couple of seconds here. All right, and here we have that second raster band layer plotted. Now we can see here in the, I guess, right-hand side of the plot, there's some area that it doesn't look like it's filled in. If we compare it to the previous plot, which will also take maybe a couple seconds to go backwards, we can see that there's just a slight difference. So this looks a little bit lighter, and then if we go to our new plot, it gets a little bit darker. So even though it's hard to tell looking at maybe these single band rasters, we are plotting different bands. All right. So let's talk a little bit about raster stacks in R. So we're next going to work with all three image bands, so the red, the green, and the blue, as an R raster stack object. And we're going to plot a 3-band composite or a full color image. So to bring all bands of a multi-band raster into R, we can use the stack function. All right, so let's go ahead and add a little subsection. So raster stacks in R. So let's create an object called RGB underscore stack underscore harv assignment operator. We're going to use the stack function. We're going to include double quotes, and then inside those quotes navigate to data \raster \harv underscore RGB underscore ortho dot tiff, and press Control Enter. All right, so it looks like everything got loaded, and here in our environment panel, we can see that now it says we have an object of formal class raster stack. So instead of those raster layers, we have a raster stack. So let's preview the attributes of our stack object. So we can do that by just calling the object name, Control Enter. And similar to what we viewed from the previous raster layer, we have a lot of information here. So we have that this is a class raster stack. We have the dimensions here, so the number of rows, number of columns, number of observations. And now we also have this fourth argument, so this is the number of layers, and there are 3 layers. We have the resolution, which is the same, 0.25 meters by 0.25 meters, the extent, the CRS, and now we have this new, some new variables here. So we have names. So this is the names of the 3 raster layers inside of the raster stack. So harv underscore RGB underscore ortho dot 1, harv underscore RGB underscore ortho dot 2, and lastly harv underscore RGB underscore ortho dot 3. And we also have the min and max values for each of these 3 layers in the raster stack, which are all the same, 0 to 255. So if we wanted to, we could also just view attributes for each individual band. So we can do RGB underscore stack underscore harv, use this at operator, and then specify at layers. Control Enter. So just moving up my console a little bit, what we see here is that we have that same information that we had for that raster layer, but now it's in a list. And we have 3 repetitions of that raster layer, 1, 2, and 3. Oops, and 3, and 3. And each of those corresponds to one of those 3 layers. So this is ortho.1, ortho.2, and ortho.3. Let me just move this down a bit. All right, so if we have hundreds of bands, which is possible, we can also specify which band we'd like to view attributes for using an index value. So instead of at layers, because otherwise, if you have 100 layers, this will keep scrolling. So you could also do something like RGB underscore stack underscore harv, and maybe we want to look at the second one. So I use double brackets, so 2 layers of brackets on either side. And I specify which layer, so I want to look at the second layer inside of those square brackets and press Control Enter. In here we see we have that same information for that raster layer, and now we're also told that this is band 2 of a total of 3 bands. All right, so now if we want to plot it, we have to, of course, convert things to a data frame first. So let's go ahead and do that. So I'm going to go ahead and create a new object called RGB underscore stack underscore harv underscore df. df stands for data frame. We use our favorite function as.data.frame, open parentheses, RGB underscore stack underscore harv, and then specify the argument xy equals true. And press Control Enter. All right, so now it looks like we have a new data frame in our environment, the same number of observations that we previously had in the other data frames we created from the individual raster layers, but now we also have 5 variables. So let's quickly look at the structure. So str, open parentheses, let's put in this new data frame we created. RGB underscore stack underscore harv underscore df. Press Enter. So it looks like each of those 3 raster layers, so ortho 1, ortho 2, and ortho 3, are now variables in our data frame. So these 2 additional variables are what comprise of the 5 variables we observe in our data frame. All right, so let's go ahead and plot it. And actually, for good reproducibility purposes, let's go ahead and add this RGB. Let's add that structure command that I just put in the console into our script. Maybe in the future we're going to forget this, so it might be helpful to have it in there. So I press Control Enter, and again I get that same information. All right, so let's first create a histogram. All right, so I'm going to have my ggplot with open parentheses plus geom underscore histogram, open parentheses. Inside the parentheses, we specify data equals RGB underscore stack underscore harv underscore df, comma AES aesthetics, harv underscore RGB dot ortho dot 1. So we want to play, that's underscore ortho dot 1. So we want to just look at a histogram for that first layer. So I press Control Enter. Again, we have our message that we might want to use a different bin size. That's okay for now. So we can see here that the min is at 0. We have quite a few zeros here. And the max is right around 255, which we know is the maximum value. So it looks like maybe a lot of the values are somewhere around, let's say 125 or so. Great. So now let's go ahead and plot. Actually, let's add some more information. So this is a histogram of let's say ortho.1. And now when we use geom raster, I actually want to do plot a raster image, plot a raster of ortho.2. So let's go ahead and do that. So it's again ggplot, open parentheses, plus geom underscore raster, open parentheses, inside the parentheses, data is equal to RGB underscore stack underscore harv underscore df, comma, AES aesthetics, x is equal to x, y is equal to y, comma, alpha. And now here I specify harv underscore RGB underscore ortho dot 2 plus my favorite chord underscore quickmap. And I press Control Enter. And now here of our raster stack, we are just plotting the second layer. All right, and here is our raster of that second layer. Now, it could be that we want to plot all three bands, the red, the green, and the blue, together at the same time to create a colored image in R. For this, we can use the function plot RGB, where RGB are capitalized. So this plot RGB function will allow us to identify which bands we want to render in the red, green, and blue regions. The plot RGB function defaults to 1 is equal to red, 2 is equal to green, and 3 is equal to blue in that band order. However, you can define bands to be whatever you'd like and plot them manually. Manual definition of the bands is useful if you have, for example, a near infrared band and you want to create a color infrared image. Secondly, this function plot RGB allows us to adjust the stretch of an image to increase or decrease contrast. So let's go ahead and plot our 3-band image. So for plotting using this plot RGB function, we're not going to need to convert this to a data frame first because this isn't part of the ggplot2 package. So the function is plot, all lowercase, and then RGB, uppercase, open parentheses. And here we're going to put in our stacked raster, so that's RGB underscore stack underscore harv, comma, and now we specify red, or R is equal to the first layer. Oops. G is equal to 2, so green is equal to the second layer, and B is equal to 3, so blue is equal to the third layer, and press Control Enter. And now we get this really cool image, right? I think it's very cool. So we can actually see that this is a raster of a forest, right? And we see that there's this sort of depressed area, or at least an area that doesn't have any trees. And this really looks like an image from a camera. So this looks pretty cool. However, we can also explore whether or not we want to stretch the image and if that might improve the clarity and contrast. So to do this, we can specify the arguments stretch is equal to lin or stretch is equal to hist. So let's try that out. So plot RGB, and let me add a subtitle. Plotting stacked plot RGB. Plot RGB. We include our stacked image here, so underscore stack underscore harv. Again, we specify R is equal to 1, green is equal to 2, B, blue is equal to 3, comma. I'm going to change the scale here to 800. And then I'm also going to add stretch is equal to lin, and lin is in quotes here. Press Control Enter. So we can see here when we specified stretch is equal to lin, this looks a little more sort of toned down a little bit less. It almost looks like an Instagram filter, right? So that is what stretch equals lin does. Let's go ahead and explore the argument stretch is equal to hist. So it's the same function. So plot RGB, open parentheses, our stacked raster, R red is equal to 1, G green is equal to 2, B blue is equal to 3, comma, scale is equal to 800. Stretch is now going to be equal to hist, and hist is in quotes. Just Control Enter here. And we see that the coloring has now changed, right? This looks like a different Instagram filter. So we can see that in this case, the stretch doesn't really enhance the contrast, and the image is already significantly contrasted enough given the distribution of the reflectance, or the brightness values, is distributed fairly well between 0 and 255. All right, so now we're ready for our second challenge. All right, so for this challenge, we're again going to review some of the previous information that you've learned in the other lessons. So no data values. Let's explore what happens with no data values when working with raster stack objects and using the plot RGB function. Well, we will use the harv_ortho_wna.tiff geotiff file in the data raster directory. So there are 7 parts to this, so take your time. So firstly, we want to view the file attributes. Are there no data values assigned for this file? 2, if there are no data values, what is the no data value? 3, how many bands does it have? 4, load the multiband raster file into R. 5, plot the object as a true color image. 6, what happened to the black edges in the data? Lastly, 7, what does this tell you about the difference in the data structure between harv_ortho_wna.tiff and harv_rgb_ortho.tiff, the R object that we created rgb_stack. And how can you check this? All right, so let's go ahead and go through the solutions for challenge number 2. Move this down just a bit. All right, so the first thing we wanted to do is to identify the information in the raster, right? So one way we can do this is to use the gdal_info function. So gdal_info, open parentheses, and then we navigate to where this new raster image lies in. So that's in data, /raster, /harv_ortho_wna.tiff. So Control Enter. Again, it looks like we have some warnings here. For our purposes, again, this will be okay. It looks like the warning basically says it looks like we're not going to have a mean and a standard deviation for this raster, but that's okay. All right. So from this object, we can see that the no data value, let's find it here, no data value. So this raster does have no data value, so this is true. And the no data value is -9,999. From here, we can also identify that there are 3 bands. So 1, 2, and 3. And then it should also say here, number of bands, 3. All right, so let's go ahead and read this file in using the stack function. So we can create a new object called harv_na, and we use that stack function, open parentheses, double quotes, data raster, harv_ortho_wna.tiff. Control Enter. All right, so recall we can now use that plot RGB function we learned about. So let's include that stacked object. So that's harv_na, comma, red R is equal to 1, green G is equal to 2 and B blue is equal to 3, and Control Enter. All right, so what's different about this image? Looks like those black values, or the black part of this raster, is no longer there, right? The black edges are not plotted. So while this raster and the previous one we worked with both had no data values, in RGB_stack, the no data value is not defined in the TIFF tags. Thus, R renders them as black, as the reflectance values are 0. The black edges in the other file are defined as -9,999, and R renders them as NA, and therefore excludes them when plotting them. Great. So let's go ahead and move on to our next section. So this is raster stacks. Versus raster bricks in R. So the R raster stack and raster brick object types can both store multiple bands. However, the way they store the bands are different. So the bands in a raster stack are stored as links to raster data that is located somewhere on your computer. A raster brick contains all of the objects stored within the actual R object. In most cases, we can work with a raster brick in the same way we might work with a raster stack. However, a raster brick is often more efficient and faster to process, which is important when working with larger files. So we can turn our raster stack into a raster brick in R using the brick function, open parentheses, and then the name of the stacked object inside. So what we're going to do is use the object.size function to compare the raster stack and the raster brick objects. So first, let's go ahead and check, let's add a comment. So let's check the size of raster stack. Oops. All right, so the function is object.size, open parentheses, RGB_stack_harv. So we first just want to check the size of our stacked object. So press Control Enter. And we can see here that it is 50,104 bytes. All right, so then let's create a raster brick. Whoops. Create a raster brick object from a raster stack data, and we'll also view its size. So let's go ahead and create RGB_brick_harv assignment operator, brick, open parentheses, RGB_stack_harv, so creating a new object here. Now recall previously a stacked object, the actual TIFF file stayed on your computer, and so some of the information about it was brought into an R object. With bricks, actually the entire object is brought into your current R session, right? All right, so here we can see that this object has now been created. So this RGB_brick_harv, and we're told that this is a large raster brick of over, 9 million elements, and then ... So it's been created. So now let's check the size. So again, we use the function object.size. This function is in base R, so we don't need to load any package for it. That's RGB_brick_harv. Just Control Enter. And here we have that this is 73,085,600 bytes. All right, so much, much larger. So notice that in the raster brick, all of the bands are stored within the actual object. Thus, the raster brick object size is much larger than the raster stack object. We can still use the plot RGB function on the brick. So let's try that. So it's plot RGB, open parentheses, RGB brick underscore harv, control enter. All right, and so this should be our brick object. It looks just the same. Oh, pardon me. This should be our brick object. It looks just the same as we previously had with that black border around the edges. But notice it went a little bit faster for us to plot. So there is some pros and cons. All right, so with that, we're ready for our final challenge. So let's go ahead and get to our last challenge. All right, challenge 3, R functions and class. So we can view various functions or methods available to use on an R object with methods, open parentheses, class is equal to class, open parentheses, object name here, close parentheses. And we can use this to figure out, 1, what methods can be used on the RGB stack underscore harv object, 2, what methods can be used on a single band within RGB underscore stack underscore harv? And 3, why do you think there is a difference? All right, so let's go over solutions for our final challenge. So which methods can be used on the RGB stack underscore stack underscore harv object? So let's add some information here. So which methods can be used on our stack object? So we can use this function methods, open parentheses, class is equal to class, open parentheses, and we put our stacked object in here. So RGB underscore stack underscore harv, and press control enter. And we get a series of over 173 different functions that we can apply to this stacked object. So these are all of the different things that we can do to that stacked object. So let's compare this to the methods available for a single band. Excuse me. So methods, open parentheses, class is equal to class, open parentheses, RGB underscore stack underscore harv. Now how do we extract a single layer from a stacked object? Let's go ahead and look at the first layer. So 2 sets of square brackets, 1, 2, and then since I want to look at the first layer, I specify 1 in here and press control enter. And here I have the whole series and set of a whole series of different functions that I can apply to my layer object, pardon me. So notice here, let's see, 173, 4, 5, 6. There are 176 methods available for my stacked object, and here there are 190 methods, available for my stacked object. So that they're not quite the same, right? I can do different things for a layer than I can for a stacked object. So there are far more things one could do or want to ask of a full stack than of a single band. So that's sort of the take-home message here. All right, so wrapping this up, this script is unsaved, so I'm going to press Control S to save this script. And with that, you are now all experts in using raster data in R.